So hello everybody, thank you for the introduction. We're planning actually to be three speakers, the third one being the agent, but it's not sure I will get the sound, so you will maybe only see what the agent writes on the screen. So indeed this is a project on the Business and Engineering School of the canton of Vaud, not very far from Lausanne. It's in Yverdon-les-Bains. And our project starts from a comparison that we did on the competencies of chatbots or chatterbots on one side and smart assistants on the other. So if I try to summarize very quickly the situation these days, is that if you play with chatterbots trained using machine learning on text corpora, on dialogue corpora, you find out that they actually have good interaction skills. They often have very well-formed replies, at least in English, but they are just doing a conversation for a very long time without actually bringing any useful knowledge or solving tasks. On the other hand, smart assistants have become very popular in the past 5 or 6 years. They're pretty good at solving the tasks for which they were designed, maybe helping you to buy some products or telling you when it's the next train to London. But you cannot really have a conversation with them, and they fail quite quickly when they are off task, as we saw yesterday in the same session. So our project actually, which is called PLACAT, aims at combining the advantages of these two approaches. So offering a task-oriented agent, which can also hold an off-topic conversation for quite a long time. So this is a project supported by the University of Applied Sciences in Western Switzerland, of which our own school is a member. So to be a bit more concrete, actually, if you play a bit with cleverbot.com, which is one of the numerous bots or chatterbots available, you can actually have a funny conversation for quite a long time. You can talk about Star Wars, for instance, but this depends a lot on the dialogues that people have actually staged with this chatterbot and what was being learned. And then, well, there are quite a number of off-topic things, but the conversation keeps going on. So what we like from chatterbots is that they're actually intended to mimic human conversational competencies. You may wonder whether they are of any use in the industry, for instance. So some people try to make them play the role of a therapist, or just say, look, they will provide you with an English conversational partner if you don't have a tandem to discuss. So we tend to look at them as some kind of instance of Mr. Chatterbox, this well-known character from Kid Stories. So we like their conversational capacities, but we don't like the fact that they're not intended to give access to any form of knowledge, for instance, as stored in a database or a service. So then we actually turned to the other way of looking at conversational assistants. So let's call them smart assistants or conversational systems. In research, they have been considered, at least for the past 25 years, for instance, to help people buy, let's say, train tickets or plane tickets. More recently, conversational assistants are supported on smart speakers, like the Google Home one, or here inside of the Amazon Echo. And, well, their conversational models are pretty good at helping the users solving the tasks that they are sort of intended for, buying in some cases, or finding information on the web in the other cases. But their capacities, sorry, maybe this is a better slide. Their capacities to have a multiple turn conversation are still very limited. So we like their super great speech recognition capabilities. Well, we like to use them for some common tasks. And when these are well done, they actually quite good at replying to some very common chit-chat questions, like, well, things about maybe if they are a robot or not, and things like that. So focusing more on the Google Home smart speaker, for which we developed our platform, we realized that to some requests for information, the answers are exact, so it's exactly the answer that we want. And in many cases, if there is no exact answer, then we actually get a quotation from a web page, which in a conversation is not such an appropriate answer. And despite the announcement that the speaker can have a continuous conversation, the multiple turn capacities are very limited. Now, the goal of our platform is to combine, let's say, the knowledge-based agent, call it little Miss Brainy, with Mr. Chatterbox, by simply taking advantage of their capacities and presenting it as a front end with a multiple, actually with a two-way choice. So our conversational system brings in a controller or dispatcher, which, depending on the recognized intention from the user, will actually send the utterance either to a chatterbot, if this doesn't seem to be like a task-related query, or to the task-based component, if this looks like a valid task-oriented query or utterance. So in our case, in our prototype, which is still a prototype and the platform, the task that we actually selected as a demonstrator is simply question answering over Wikipedia. So we're not yet focusing on a corporate scenario or on a specific domain. We're trying to answer general knowledge questions, provided the answer is in Wikipedia, which is, of course, pretty vast. And we actually subcontract all the interaction management to a chatterbot component. So in addition, we'd like to actually have this as an agent on the smart speaker, which enables the voice-based interaction. But text-based works fine as well. So in the following, Gabriel will give some technical details on the component of our system. So first, the voice-based front-end and the connection to the smart speaker, and then the capacity to direct the user utterances through dialogue act recognition, either the question answering component based on neural networks, or to a chatbot for the non-task related utterances. So following this, following Gabriel, I will give some details about preliminary evaluation and hopefully take some minutes for a demo of the agent.
Okay, so I'm going to go through the infrastructure of our system. So as Andrei said, we use the Google Home smart speaker. So it allows us to do a small app called Actions, which are connected to the platform Dialogflow, which maybe some of you learned to use yesterday in a workshop. But we don't use any tools provided by the platform. We just directly send all the user utterances to our server, which process them and then respond to Dialogflow and so through the speaker. Next, the controller, which is the main part of the system, and whose goal is to dispatch either through a chatbot or the question answering module. And so we needed to do that because it's not a great idea to answer to questions like how are you, or are you a robot, yielding some knowledge source. We won't get any good result with this solution. So we need to dispatch to the correct module, and in order to do that, we implemented binary classifier. And so we trained it over 25,000 occurrences and obtained 90% accuracy, so it was quite good. And so for the chatbot component, its goal is to deal with chit chat or politeness, all these kind of occurrences. And yeah, result varies, but usually it's quite okay. At least it answers something, and it's implemented using a sequence-to-sequence neural model, and it has been trained over 500 million words from a movie dialog corpus called Open Subtitles. And next, for the question answering part. So its task is to information access, and as Andrei said, we use Wikipedia to retrieve, to get the knowledge, but it can be maybe later adapted to any given field or some company documents to get information. This part has two components. The first one, we use Elasticsearch to index Wikipedia and to retrieve, hopefully, the correct page that might contain the answer of the question. And then we use BERT, so the language model made by Google, to retrieve exactly the answer over the paragraph. And so BERT has been fine-tuned to this task using the Squad dataset, which contains over 150,000 questions. And the main challenge of this module is for Elasticsearch to retrieve the correct page or the correct paragraph, because if it's not the right one containing the answer, BERT won't be able to do anything. And for that, we have a few design options available, and we try to optimize it based on some results we'll see later.
Okay, so then my turn to tell you something about the results. Well, on the research side, of course, we're quite interested in measuring the performance of this type of system. Of course, this should come with actually real users on a real scenario, but we were interested in finding out at least about the question answering capacities. So actually the model that is trained on BERT, the best models based on it reach about 87% accuracy in finding the answer to a specific question. However, these numbers are obtained given the paragraph that contains the answer. So in the official evaluation setting of BERT for question answering, the paragraph containing the answer is given to the system. Of course, in our case, that's absolutely not the case. So although our system in the same conditions reaches above 70% accuracy, when we combine it with paragraph retrieval, it's more like 50% accuracy. And in fact, these numbers hide some large differences between questions which are not answerable. So the correct answer is I don't know. That's quite an important feature in systems. So that most of them we get right. But actually on the answerable questions, we still have work to do on the retrieval component actually to get the paragraphs. So there we have quite a large proportion which is not answered correctly. But this is to show also how we set up our various options in the system. So the options of the retrieval component and the options of the answer extraction component. So before I turn on to the demo, which will conclude the talk, I just wanted to mention our main perspective, which is actually to find one or more use cases in collaboration with a corporate partner. So typically to focus our document database from the whole Wikipedia to, let's say, the set of contractual documents of a company, And so trying to be able to answer questions from users without breaking down when the users start moving off topic and starting actually trying things which are off topic with the agent. There is also a perspective to apply this to a setting which has been promoted by Amazon Alexa, which is to have an entertaining yet informative conversation for the longest possible time. So do a bit better than the chatterbot I showed at the beginning. So it's still work in progress, but Gabriel managed to roll out the first version last week to demo. So I wanted to show it here. Basically, okay, there is a, sorry, okay. Trying to do it. So actually the Google Home speaker comes with the development platform, which allows people to design new actions for the speaker, either connected to Dialogflow or directly to our own server. And this provides a simulator in which you can use voice or text. So if I don't manage to get the sound to you, maybe you will just be able to read actually the text from it. But normally it's well, it's intended to be used as well, using voice. So let's try something like okay, whatever. Yeah, I think it's on. So hello, how are you?
Let's get the test version of Agent PLACAT. Welcome, ask me anything.
Hello, how are you today? Hello, how are you today?
Hello.
Okay, so what is Winterthur?
I don't know.
Where is Winterthur?
Canton of Zurich.
What is the population of Winterthur?
108,000.
Are you a robot?
I am not a girl.
Okay, do you know about penicillin?
I know
What is penicillin?
a group of antibiotics which include penicillin G, intravenous use, penicillin B, used by mouth.
So the answers are extracted, but of course you get to see that they come from some text. Who discovered penicillin?
Alexander Fleming.
Okay, so we can go on for quite long. When did Alexander Fleming discover penicillin?
1928.
So that's correct. But in fact, it's not really limited to any particular topic. So you can ask it things from Wikipedia. But then when you start things like, are you hungry?
I am not you.
Yes, be hungry. I'd like to go to lunch.
No, it really.
Well, thank you. Bye-bye.
Goodbye, come back anytime.
Okay, so you get a sense of it, information and chit-chat. And okay, and with this we conclude our talk. So thank you.
Just coming back to the example with Alexander Fleming, would it have been possible to just ask when did he discover the penicillin? Or
Yes.
did he discover it?
Yeah, totally. Yeah. So no, it's not possible at the time due to this dispatching to one or the other of the agents. But it should be possible sometime soon. The axis of attack I would say. So in fact here, when we just make a binary decision, we actually plan to expand the abilities of the controller, and in particular here detect whether it's a new question or whether it's a follow-up question. It's not too difficult actually to inject this knowledge. Now if you ask when did he discover it, okay, then you have two pronouns and it becomes trickier. So yes, this knowledge of context is something quite important to users, so more work on it.
Rather than considering just the current answer, it is possible to consider all the interactions so far from the text point of view and then manage like resolution and then see whether it is linked to something in the past or something which is not yet mentioned. And then your binary situation can be done on this side and then you solve this.
Yes, thank you. I love co-reference resolution. So actually, yes, it's something that can be done. Not necessarily our primary goal, because our primary goal was really to basically manage the two aspects at the same time. But of course, if we had to roll out a real product, then we should manage pronouns. Yes, along the lines that you mentioned. So implementing some kind of basic lookup in the context.
Something that comes to mind is you try to use the controller to send the conversation one way or the other. Another way of doing it would be that you send the conversation to both, and then you decide which reply you want to play back, right? Because you don't really know a priori how each of these are going to react, and it's perhaps more interesting to do it ex post. Just an idea.
Or combine both, so that
Yeah,
it gets
yeah.
interactive and informative.
Yeah, I'm not clear whether you can combine one, because the question
You
is,
summarize. You phrase.
yeah, because the thing is, the dialogue management might be different from both sides, etc. So it might not be as straightforward to combine, but at least you can take expose. Yeah.
So yeah, indeed, yeah, I think that's a great suggestion. Well, keep in mind that both things are end-to-end trained, and so there is no real dialogue modeling in the traditional sense. Yeah, exactly. Yeah, that's the whole point in those end-to-end systems. But that's also their strength, because it means you can train them on corpora that are very specific to your user and your task. But indeed, making a decision ex post, as you said, it's an interesting point. So it's something that we can.
But it's also quite hard to give a score afterwards, because the chatbot almost always gives something, and so you have to find a way to judge it if it's good or not.
Exactly.
And so it's a
But
difficulty.
you have something called to pick and choose from instead of trying it. That's one thing. And secondly, now that you say you have to dialogue management, perhaps you can add some kind of meta dialogue management, right? That allows you then to pick the responses.
There's one question.
I think it was us.
Hold on. Okay. Any other question? Okay.
Is this an open source framework, and are you opening it to the community, or is it still some kind of internal research project?
The two components are actually based on third-party code, so it would be only the classifier itself which we could release actually. So anyway, we're quite open about how it works. So this is the research aspect of it. We can share it.
Thank you so much for